kids, Miss Kulkarni here. In this video, we will continue to learn more things about atomic theory and atomic structure. But our main focus is going to be on changing the atomic structure. And how are we going to achieve that? We are going to change different atomic particles. So here, the very first thing is we will change the number of neutrons. And what do we get? If we change number of neutrons, we end up getting substances which we call as isotopes. And this is an example of isotopes: carbon 12, carbon 13, carbon 14. The 12, 13 and 14 is nothing but it's a mass number. So what are isotopes? They differ in the number of neutrons and therefore the mass number is also different for them. In general, isotopes behave chemically almost the same. And how do we represent isotope? It's always the name of the isotope followed by a hyphen and then the atomic mass number. So we got 12, 13 and 14 as three different mass numbers for carbon. Now the atomic mass number is number of protons plus neutrons. So in case of carbon 12, P plus N is 12. In case of 13, it's P plus N equal to 13 and so on. And then atomic number for carbon is 6. What information we get from atomic number? Atomic number is equal to number of protons. The atomic number for carbon is 6. So we can write down proton is 6 for each of those. That gives us number of neutrons as 12 minus 6, which is 6 here. For this one, it will be 13 minus 6, which is 7. And for last one, number of neutrons is 14 minus 6, which is equal to 8. So look at that. Each carbon isotope has different number of neutrons, 6, 7 and 8 respectively. So what is an atomic mass and how do you find that out? Atomic mass is the one which is listed in periodic table. And it is in fact the average of the masses of all the isotopes weighted by their percentage abundance. How do we calculate that? It is simply the sum total of the product. And product of what? It is a product of fractional abundance times the mass of each isotope. And there it is. We end up getting the atomic mass. So fractional abundance is percent divided by 100. What it means is if you have 80%, that means the fractional abundance will be 80 divided by 100 or it will be 0.80. Now another thing to keep in mind, if the percent is 100, the fractional abundance should be equal to 100 divided by 100, which is equal to 1. Okay. Here's the problem of finding the isotopic mass of chlorine. So we have chlorine 35 and chlorine 37. Let's write down that. And we know the percent abundance for each of that. So let's list that. Percent 75.53%, and over here this is 24.47%. Now with that, how much is the fractional abundance? We divide this number by 100, which will easily give us 0.7553, and over here this is 0.2447. And then we need to find out the mass of each isotope. So for chlorine 35, the mass is 35, and for chlorine 37, the mass is 37. What we are going to do is we are going to actually multiply these two and these two numbers, and then we're going to add those two things. So the average atomic mass will be multiplication of these two numbers, the fractional abundance times the atomic mass, and to that we are going to add the fractional abundance for the other isotope times the mass 37. And when we solve and work on that, what we get is 35.49. This is the average atomic mass of chlorine, and which is what is listed in the periodic table. Okay. In this problem, we have been given neon with 3 isotopes, and those are the masses for neon, and the percent abundance is given for each of those. Let's put that into table. So we got neon 1, neon 2, and neon 3. Let's get the percent. 90.92, 0.25, and 8.83. That means the fractional abundance will be 0.9092. Remember, we take this and we divide that by 100. This will be 0.0025, 0.0883. And then we got the mass as 19.99, 20.99, and 21.99. Now your job is to multiply these and add all those numbers. So if you list those in a linear manner, this is what we end up getting. And when we solve that, the final answer is 20.17. Let's work on one more problem. And here we have been given silver isotopes Ag107 and 109. It also gives you the accepted atomic mass of silver as 107.87 AMU. This is what will be listed in periodic table. And our job is to find out the percent abundance for each of the isotope. Let's list that all information in this table. So we have silver 107 and silver 109. With that, the mass is 107 and 109. And if the fractional abundance is X for this and Y for that, so we actually multiply the mass with fractional abundance and we add it with the other isotope, and what we end up getting is the actual real atomic mass, which is given to us as 107.87. We also know one more thing, X plus Y is the fractional abundance for which the sum total will be equal to 1. Now in order to solve the equations, we can multiply this equation by 107. And if we do that, we get 107x plus 107y equals 107. And now we subtract the second equation from the first one. So that's gone. And over here we get 2y is equal to 0.87. So y is equal to 0.435. You can find out using that value for x. X will be 1 minus 0.35, which is 0.565. And how do you find the percent abundance with that? It is the fractional abundance times 100. So for y, the value is 43.5%. And for x, it is 56.5%. So I hope you guys enjoyed the video. I will see you in next video. Until then, bye-bye.